is there a specific process that you were taught in school that helps you to tackle complex problems?
I guess you could definitely break it down into a few different states. There's a presentation I have on like technical SEO problem solving, which I think kind of outlines that more clearly. I wish I had it in front of me now because I'll probably forget a step. The first step being like figuring out what the problem is actually asking of you. And I think that can happen a lot of times in like data analysis, that like you have this data, you have it segmented in a bunch of different ways, but you need to figure out like what question are you trying to answer? Like what is the insight? So that can help with that type of thing. So figuring out the problem that you're trying to solve, then establishing what do you have? What data are you given? I mean, this is very traditional with math, but like you're given everything but the thing you need to solve the problem, which I guess doesn't always exactly fit in the real world. But the whole idea is to think like, okay, what do I have? But then also like, what do I not have? What can I get? What can I not get from the problem? There's a book on, I can't remember its title, but it's basically like how to be amazing at math or something. I'll send you the official link so people can find that. But the example that he uses is basically about how in World War II, the Americans had set up this camp of scientists where they would go in and perform statistical analyses and math and do all this crazy stuff to help the US military. And they had this guy who was like a crazy genius who just like the way he was able to synthesize problems was just like out of this world. And so all the mathematicians like looked up to this guy. And he went through, and they all went through this exercise. They had received all of these planes back, all these airplanes that had been shot, and basically had established like, okay, well, we have all these airplanes shot. Let's do some analyses on where they were shot to see where we can buff up the armor so we can be most efficient with our costs. And so all these statisticians went through and they said, okay, so we have all these numbers, all these places on the airplane, and we think because we have almost no bullet holes on the engines, that we should take all the armor off the engines and put them in other places. And this guy who was like this mathematical genius came in and he said, all right, and he like looked at all the data and he's like, well, what you guys aren't thinking about is not just the bullet holes, it's the fact that what about all the planes that didn't come back? So that idea of thinking about what's not there is also really important. And the reason in this particular case that they didn't have any planes that were reclaimed with bullet holes in the engine was because they blew up. So there were no remains. So that was actually a very important part of making sure those parts were armed. So just kind of like, he gave that as an example of mathematical thinking and how in school that's what they're kind of trying to teach. But in the end, like unfortunately, partially because there's a lot of math that's been built up that we're kind of standing on the shoulders of giants like Isaac Newton, obviously. But part of that reason is that we have all these issues because we don't understand the history. Like we never have to fight that a negative number is real. So why would we question it, or think about it or process that information? Whereas back in the day, like that was a huge question. Like nobody knew how to deal with them. Like whole numbers and natural numbers were like where it was at. So not knowing what you don't have is also important. And then beyond that, trying to set up some sort of formal equation, something that you can solve from there, and then trying to actually solve the problem.
I love it. And the airplane example is my favorite example for biased samples in statistical testing. That is so perfect that you allude to that, but also like your step-by-step process for solving complex problems. And kind of
Look at
reminds.
the deck. It covers everything, and it's in technical SEO terms too. So,
But I think it's so applicable to everything else as well, right? And that's what I like about SEO. We're dealing with lots of variables and lots of uncertainty, and we have a lot of complex problems. And one of the biggest mistakes that I see is that people don't spend enough time to correctly phrase the question that they're trying to solve, or correctly even phrase the problem. You know, it's oftentimes. And by the way, I see this in management and in companies and in work in general as well, you know. But specifically in SEO, it's often like, oh, okay, fix this canonical because it's wrong. And okay, that's a very specific use case. But then you come back to, okay, why, you know, is that page even important? And how does it play into the market strategy? And how does it play into the company strategy? Like, what's the whole purpose of it? And what's the actual problem? Is it that the canonical is wrong? Is it that there is a faulty logic in the system or in the backend that places wrong canonicals? Is it that somebody has access to the CMS and sets canonicals manually? You know, like, so they don't, I feel like the zooming in and out and thinking laterally and horizontally vertically is something that a lot of people don't do often enough, and would probably help a lot with solving complex SEO problems.